Hi there. In working with integrals some more, section 5.4, we're going to be looking at even and odd functions, seeing what happens with those. So with a perfectly even function, note some sort of even function, it's the same on either side. I could integrate if I want to know what the area under the curve is from negative a to a. Then I don't have to integrate the whole thing. I could just integrate from 0 to a and just say that it was twice that, or 2 times whatever that area is under just one. If it is a perfectly odd function, note that I have just as much on the above the axis as I do below the axis in terms of area, and that means that my total area is 0. If they were wanting net area, that would be a little different. It would be very similar to the even, and basically that's what it is, and it would make it twice that. All right, so let's look at a couple of examples that use that. All right, here's our examples. I'm going to break this into two parts. I'm going to look at negative 2 to 2 x to the fourth dx minus from 2 to negative 2 3x cubed dx. The very first one happens to be, I'm going to be using symmetry, so they told me that's what I have to do, so I'm going to do that. This is an even function, so if this is even and this guy right here is odd with just a 3 multiplier, then I know that this guy's going to be 0. And for this x to the fourth, I can just say that it's 2 times whatever it is from 0 to 2 x to the fourth dx. And carrying on with that, that would be 2 times x to the fifth over 5. And then I'm going to evaluate that from 2 to 0 and then just plug those numbers in and crunch out the answer. Okay, now I've done the arithmetic for you, and we get 64 over 5. Alright, I'm going to play the same game here. I'm going to break this into two separate pieces. So it'll be from pi over 2 to negative pi over 2 cosine x dx minus, and I'm going to go ahead and pull that 4 so that I can just look at it as the symmetry that it happens to possess. Negative pi over 2 sine cubed dx, oops, x dx, there we go. This first one is another even function, so I'll use that even symmetry. This happens, sine happens to be an odd function to an odd power, and this result is also going to be odd. So I know that this chunk goes to 0, and using symmetry here, pi over 2 to 0, it would be 2 times whatever this would be. So integrating that, it would be, let's see, what would the derivative, the integral of cosine would be sine, making sure that my signs are all okay on that. And they are, and I'll be evaluating that from pi over 2 to 0 and then doing the arithmetic of that. Alright, and there we have it, just plugging in the pi over 2, get a 1, plug in the 0 to get a 0, and there's the area for this entire function here. This definition has to do with the average value of a function, and what they mean by the average value, we're talking about the average y value. If I happen to know the area, and so let's say I know that the area, and I know that the area is, let's say, length times width, and let's just say that this is the, we'll call it the length. That's the length. Then in order to get that average width, even though it goes up and down, in order to get that average width, I would take the area and divide it by whatever that length is. Notice that's exactly what this is right here. It's just dividing by that length. So I'm getting the average y value, or the average In this case I called it width. I don't really care which one you call it, but I'll be getting the average y value by dividing by whatever this distance is here on the x-axis. So let's see if we can get the average elevation of a trail given that the hiking trail follows this function. It's interesting that we know the function that the trail follows and yet we don't really know the average elevation, but whatever. And I need to know it from 0 to 5, so I'll be looking at it from 5 to 0, 5 to 0, and then I will just integrate all of this. Dx with respect to x. So this will give me 1 over 5. And I'm just going to do each of these independently. So it'll be 60 x to the 4th over 4 minus 650 x cubed over 3 plus 1200 x squared over 2 plus 4500 x evaluated from 5 to 0, and I'm going to do that arithmetic. After plugging those values into my calculator, I get 3,958.3 feet. And that gives me the average value of that function. On to the next and last thing. Okay, the mean value theorem for integrals. We're finding the average function value, so let's just say we're looking at it from this A to B somewhere, and we don't really care where it is, but let's say the function makes this kind of move here. And then we get the average. Well, first we get the area. So let's say we have the area, and then we find the average height of that. I know that the average height is probably going to be somewhere in this realm because I'm going to have some below it and some above it. What the mean value theorem says, it says when you get that average height, there must exist, as long as it's continuous, there must exist some c where the average height is on that function line itself. And in my case, what I drew had a C1, a C2, and a C3. So that's what that's saying. It's saying there must be some place in there where if you have an average height, there must be some place in there where your actual function value equals that average. Okay, so we're going to use that to find the points on which this guy actually equals the average. So first off, let's figure out what that average value is. So the average value is going to be integral of, and it's on 0 to 1, so I'm going to do 1 to 0, 1, 0. I'm not going to use that. I'm going to use 2. I'm going to go ahead and multiply it, minus 2x squared, because I have to do it anyway in order to integrate, and that would give me 2x squared over 2 minus 2x cubed over 3 evaluated from 1 to 0. And this average value is, so you guys cancel, and it would be 1 minus 2/3, which would then be 1/3. So the average value is 1/3. So this is the average y value. So they're wanting me to find, so this is the y value. Give me the x values where this happens. Okay, so I need to know where f of x equals 1/3, so I'll say 1/3 equals, and I'm going to go ahead and write 2x minus 2x squared, and I've got to figure out what those x's are. I see that I have a quadratic. I'll go ahead and shove everything over to one side, doesn't matter which side, but I happen to like positive x squareds. And now I either factor this or I plug it into the quadratic formula, and then I figure out what those x values are. So let me do that. So for this particular function, after I use the quadratic formula, so I'll do quadratic formula yields that, which is x is about 0.211 or 0.789. You will get those values that are actually equal to the average value. And that is it for section 5.4, a rather short section that was really nice for a change. And hope to see you in the Collaborate. Thank you for listening, and see you soon. Bye.